Approximate aircraft dimensions are: the wingspan of the L-1011 is approximately 155 feet, with a maximum fuselage diameter of 20 feet. The height is 55 feet, and the overall length is 179 feet. The minimum pavement width for a 180-degree turn is 142 feet. This assumes the turn is being initiated with the airplane in motion at approximately idle thrust and no differential braking. It should be noted that the wingtip turning radius is larger than the nose turning radius. Therefore, nose clearance does not ensure wingtip clearance. The tips of the wings are not visible from the flight station. Due to the high velocity of engine exhaust, consideration must be given to power application in the terminal or ramp areas. Gale force winds of 50 miles per hour exist as much as 100 feet behind an idling engine. This point for a wing-mounted engine would be approximately 20 feet aft of the aircraft tail. For this reason, it is recommended that breakaway power be derived from the wing engines. At takeoff thrust, wind velocity of 100 miles per hour exists at 300 feet aft of the tail and decreases to approximately 35 miles per hour as far aft as 1,100 feet. The forward cargo compartment, the lower galley, the mid and aft cargo compartments are located in the area under the floor. The forward and mid cargo compartments are for containerized or bulk cargo. The aft cargo compartment is for bulk cargo and pets. All cargo compartments are Class D. Located under the flight station is the forward avionics compartment, which is accessible in flight by a hatch in the flight station floor. The mid-avionics compartment is located in the center of the fuselage. It, too, is accessible in flight by a door located in the lower galley. The hydraulic compartment is located in the area between the main gear wheel wells. It is a non-pressurized area and is not accessible in flight. Access to the hydraulic compartment is through two doors on the underside of the fuselage. The mid-avionics compartment external access door is under the right wing leading edge. The lower galley door is on the right side of the fuselage, forward of the right wing leading edge. The forward avionics compartment external access door is on the bottom of the fuselage, aft of the radome. This access door can only be opened from outside the aircraft. All three cargo compartment access doors are on the right side of the aircraft. These doors are normally opened and closed electrically. If a cargo door actuator fails, the door may be manually cranked open or closed by use of a hand crank, stowed in the forward avionics compartment. Passenger doors are identified as 1 through 4, left and right. For example, the L1 door is the forward left entry door. The first 3 doors on each side are double-width entry doors. The L4 and R4 doors are single-width emergency doors only. They are all plug-type doors. Flight station. The flight station is arranged in the conventional manner for a crew of 3 with 2 observers. The flight station door contains a window that is normally covered by a hinged mirror on the flight station side. Next to the mirror is a key pouch for the flight station door key. Below the mirror is a wide-angle viewer used to scan the cabin aft of the door. A slide bolt is located above the doorknob for positive securing. The doorknob has a key lock on the cabin side and a manual lock lever on the flight station side. The manual lock lever prevents the knob from turning. The door frame contains a lock plate that houses a solenoid-operated door latch release and a mechanical lock lever. The flight station door is normally held in the locked position by the engaged solenoid. When the solenoid is de-energized, the door latch is released, allowing the door to open. The mechanical lock lever, when moved to the locked position, prevents the door latch from releasing. On the aft right corner of the console is the momentary door released button, which de-energizes the solenoid, allowing the door to open. Seats for 2 observers are provided in the flight station. The first observer's seat is elevated to provide the occupant with an over-the-shoulder view of pilot activity. Under his seat is stowage space for crew luggage with a retainer strap. Behind the seat is a coat closet. The second observer's seat, adjacent to the entry door, has a folding seat bottom that stows when not in use. On the floor in front of the flight station door is a hatch which provides access to the forward avionics compartment. Fastened to the bottom of this hatch is the MCO pouch. On the right aft portion of the flight station is a coat closet and a hat shelf. The floor of the coat closet is not to be used for storage, so no retaining straps have been provided. Forward of the coat closet and to the right of the second officer station is a flight kit storage area with a retaining strap. Illuminated approach chart holders are stored in the side consoles and can be mounted either on the top of the control columns or on the side consoles. An eye locator is provided to position the pilots for optimum visibility. With the pilot seat properly positioned, optimum runway visibility and an unobstructed view of the engine and flight instruments is assured. The pilot's eye locator is an illuminated two-way sight mounted below the compass on the windshield center post. The switch on the eyebrow panel controls the light in the eye locator. The eye locator will be demonstrated in the simulator. With the pilot's position adjusted to the eye locator, forward visibility will be 28 degrees up and 21 degrees down. This means the first visible ground object will be 42 feet in front of the nose. On an ILS approach with a reported 1200 RVR at 100 feet, the first visible ground object will be 420 feet in front of the nose, resulting in 780 feet of ground visibility. At touchdown, with a body angle of 8 degrees, the pilot's eye reference will be 32 feet above the ground. The nose wheel will be 10 feet off the ground, and the first visible ground object will be 130 feet in front of the nose. During rollout and taxi, the pilot's eye reference is 19 feet above the ground and 22 feet forward of the nose gear. The nearest visible ground object will be 42 feet in front of the nose. The captain and first officer seats operate identically. Vertical and longitudinal travel adjustments are normally electrically actuated. The same vertical and longitudinal adjustments have manual backup levers. 4 additional manual adjustments are provided. They are thigh adjustment, lumbar adjustment, recline adjustment, and the armrest adjustment. The seats will be demonstrated in the simulator. The second officer's seat has manual controls and travels along the floor on diagonal tracks. The seat also swivels and has 5 stops. This seat will also be demonstrated in the simulator. All 3 crew member seats have the same restraint system. This consists of a dual shoulder harness with inertia reels, a lap belt with retractors that has lock levers to lock its position, and a crotch strap with retractor is also provided. The circuit breaker panels are numbered from forward to aft. Circuit breaker panel 1 is over the pilots and is called CB1. Circuit breaker panel 2 is over the second officer and is called CB2. Circuit breaker panel 3 is to the right of the second officer's seat when he is facing the panel and is called CB3. An alphanumeric grid reference is used to locate individual circuit breakers. Letters are along the right side of the panel, starting with A at the bottom. Numbers are along the bottom of the panel, from left to right, starting with 1. The circuit breaker panel number precedes the reference. For example, circuit breaker 1A7 would be circuit breaker panel 1, row A, column 7. Since circuit breaker panel 1 is within reach of both pilots, the left side contains the captain's flight instrument and avionics circuit breakers, and the right side contains the first officer's flight instrument and avionics circuit breakers. The center column contains circuit breakers pertinent to all 3 crew members. Circuit breaker panel 2 contains those items less critical. The same alphanumeric grid reference is used to locate individual circuit breakers. Those items which must be readily accessible to the second officer are found on circuit breaker panel 3. Circuit breaker panel 3 also uses the alphanumeric grid reference system to locate individual circuit breakers. Flight station panel switches. There are several different types of switches used on the L-1011. All of these different types can be seen on the APU panel. These types are button, selector, toggle switch, and switch light. The switch light may be new to you, so it will be explained. A switch light assembly consists of a switch with a lens cap. The lens cap may display a maximum of 2 legends. The message may be either a word, a flow bar, or an in-transit indicator. A chrome bezel distinguishes a switch. A switch may be of the momentary or latching type. A black bezel distinguishes an indicator only. An indicator has no switch function. Spare lamps are located in a drawer under the second officer's work table. Two panels have guarded switches with cautions that must be observed when relamping. The cautions read, "Do not relamp with power on," or "Pull CB 1B14 before relamping." When a malfunction occurs that is outside the normal vision of the pilot, a light on the pilot's annunciator panel will flash for 10 seconds, then remain on steady until the fault is corrected. The light from a fault not corrected can be extinguished by pressing the reset button. An exception to this is the green Engine 2 fail-armed light. It is green because it is a normal condition not requiring crew action. It does not flash and will not reset. The Warning Caution Advisory Light's test switch serves two functions. One is to test all the forward and overhead panel lights and the pilot's annunciator lights. The second function is to recall any light on the pilot's annunciator panel which has previously reset and for which the fault has not been corrected. This light's test will automatically be terminated at the end of 5 minutes to protect the lights from overheating. The second officer's annunciators are somewhat different from the pilot's in that when activated, these lights illuminate steady and will remain illuminated until the associated door is closed and locked, or the effective system fault is cleared. The upper portion of the second officer's annunciator panel indicates door lock status. The lower portion indicates system faults. There are a number of oral warnings. Each of these warnings will be covered in their respective sections later in the program. An oral warning test panel, located at the second officer's panel, permits testing of certain oral warning sounds. It does not test the system or equipment. When the test button is pressed and held, it will sound the oral warning for the system selected. The unsafe takeoff position is unique, since it also tests the cargo door open and elevator light circuits for integrity. When selected to unsafe takeoff, pressing the test button will cause the 3 cargo door open lights to illuminate, the elevator light to illuminate, and the unsafe takeoff oral warning to sound. This confirms the system's ability to enunciate if a cargo door was unlocked or open, or if an elevator is jammed. The oral warning sounds as a result of the test only, and will not sound with an actual cargo door open condition. The oral warning will sound with an actual unsafe takeoff condition. The aircraft has 3 categories of aircraft lighting. Normal interior and exterior lighting is powered from the main aircraft load buses. Instrument standby lighting is powered from the standby bus. Cabin and cockpit emergency lighting is powered by separate battery packs located throughout the cabin and galley. The captain and first officer's glare shield, utility, instrument, and floodlight controls are at each side of their instrument panel. The center console backlighting and engine instrument panel lighting controls are located below the parking brake knob. The individual cockpit lighting controls will be demonstrated in the simulator. The overhead on-off button controls the overhead light located in the flight station ceiling. A similar on-off button is located just inside the flight station door on the right-hand side. The intensity of the overhead lights is controlled by the overhead rheostat. There are 3 normal lighting control panels on the pilot's overhead panel. The first one to be discussed will be the center console flood. The center console flood panel contains a recessed floodlight and control rheostat, which floods the center console as shown. The second normal lighting panel is the lights panel. The lights panel contains the control rheostat for the overhead panel backlighting. The third normal lighting panel is the interior lights panel. The interior lights panel contains controls for the magnetic compass light and the eyebrow panel backlighting. This panel also contains the fasten seat belts and no smoking switches. Activation of either of these switches illuminates the corresponding cabin size. The guarded thunderstorm switch, when latched, will bypass all dimming controls and will illuminate all lamps to full brilliance. The instrument standby lighting system provides panel illumination in the event of a power loss. When activated by a loss of the DC essential bus, the forward instrument panels, the standby compass, and the second officer's panel are illuminated. These floodlights will now be powered by the DC standby bus. The switch permits selection of either dim or bright. The second officer's lights panel is located on the auxiliary panel at his station. There are controls for all lights, as well as for the 3 circuit breaker panels. This panel also contains the lamp test switch for the caution, warning, and advisory lights at his station. Emergency lighting. The emergency lighting panel is located on the eyebrow panel and consists of a 3-position guarded switch and an unarmed light. In the arm position, the system is armed to activate all cabin and flight station emergency lights with the loss of DC essential power. In the on position, the system is activated. The flight station has a single light located above and aft of the captain. Once activated, the emergency lights will operate for approximately 20 minutes. To reset the lights or to deactivate the system, off must be selected. There are 2 cabin switches and 1 lower galley switch that can activate the emergency light system. One switch is located on each cabin lighting panel near doors L1 and L4. The lower galley switch is located in the galley between the lifts. Once activated by a cabin or galley switch, the system can only be reset by the flight station switch. The emergency lighting system has several independent battery packs that power lighting for evacuation of the aircraft, including slide raft evacuation areas. Exterior lights. The exterior lights panel is located on the eyebrow panel and contains all the controls for the exterior lights. There are 8 position lights installed on the wingtips, 4 on each side. The aft position lights are white. The 2 left position lights are red, and the 2 right position lights are green. When the position light switch is latched, 6 of the 8 position lights are illuminated. The remaining upper red and green position lights will be illuminated when the anti-collision switch is latched. 2 anti-collision lights are located on the top of the fuselage and 2 on the bottom. Strobe lights are located on the leading and trailing edges of each wingtip. 1 fixed position landing light is installed in the leading edge of each wing fuselage fillet. There are 2 fixed position lights on the nose gear that serve as high-intensity landing lights and lower-intensity taxi lights. Runway turn-off lights for side vision are also installed in the wing fuselage fillet directly above the landing lights. Wing floodlights are placed on each forward side of the fuselage to illuminate the wing leading edge and engine areas. Wheel well lights are located at each main landing gear and the nose gear. Let's take a quick look at the passenger cabin. 2 aisles run the full length of the cabin and are intersected by 4 cross aisles, 1 at each door. There are 12 flight attendant seats in the cabin. A single seat is located at each passenger door, shown in amber. Double seats, shown in green, are located at the center and aft cross aisles. Flight attendant control panels are located at the L1 and L4 doors. They contain the lighting, PA, entertainment, and electrical controls for the cabin. There are 7 lavatories, 2 forward and 5 aft in the passenger cabin. In the center of the cabin is the upper galley, shown in amber. The upper galley contains 2 lifts for access between the upper and lower galley. The lower galley is complete with refrigerators, ovens, and storage facilities for all meal and beverage carts. This is a view of the lower galley looking aft. Above each folding attendant seat is a galley circuit breaker panel. Items found on these panels are basically for cabin and galley equipment. The seat on the left lifts up, providing in-flight access to the mid-avionics compartment. Two galley lifts provide accessibility between the lower and upper galleys. They are fully independent and may be operated simultaneously. Each lift may transport either one service cart or one attendant in either direction. Internal controls are provided inside each lift. The external directional control switches are located on panels between the enclosures at both the upper and lower galley levels. The upper galley control panel has a key switch to power both lifts. Power either one or remove all power. The key is located in the upper galley storage compartment. To operate the lift from the inside of the lift, make sure the lift door is shut and latched. Place both hands, one on each assist handle. Place thumbs on the toggle switches above each handle and press and hold both switches simultaneously in the desired direction until the lift comes to a complete stop. The lower galley lift control panel has the same directional control switches as the upper panel. In addition, it contains motor selectors. 2 motors designated A and B drive each lift. Should one motor fail, the operating motor should be selected. The lift will operate at half speed. It takes approximately 7 seconds travel time between levels with both motors operating. Hand cranks are located below the lower galley lift control panel to provide a manual means of raising or lowering the lifts. Waste system. The wastewater panel is located on the second officer's lower instrument panel. It contains the waste pump indicator lights. The wastewater panel also contains the drain mast heater switches, which will be discussed in the ice and rain protection section. There are 2 toilet waste tank systems. The forward system provides waste holding and flushing capabilities for the 2 forward toilets. The aft system also provides waste holding and flushing for the 5 aft toilets and consequently has a larger storage tank. Except for the tank capacity, the systems are identical. Each system has 3 flushing pumps, which alternately respond to flush signals. If a pump should fail to flush a toilet when signaled, the controller will drop that pump from its sequence and illuminate the appropriate forward or aft wastewater pump light. The next pump in sequence, if available, will be signaled to operate. Water system. A 150-gallon water tank is located outboard of the lower galley on the left side. When fully serviced, the tank will contain 100 gallons of water. The remaining 50-gallon volume is used for charge air pressure. 2 air compressors pressurize the tank to approximately 35 psi. Both pressure and quantity are indicated on the potable water system panel located next to the lower galley sink. Two compressors pressurize the water tank. Water then flows forward and aft through individual shutoff valves located directly under the water tank. Additional water shutoff valves are located in the galley lift shaft and at each service center and lavatory. If either water compressor fails, the remaining compressor will continue to pressurize the tank. The water distribution lines are protected from freezing by dual-element water line heaters in the unheated areas. If one of the heater elements in the water line heaters fail, the other heater element will continue to provide adequate heat. Lights associated with the water system are the 2 water compressor lights and the water line heater light on the second officer's annunciator panel. If either water compressor fails, its respective legend will illuminate. If one of the dual-element water line heaters fail, the water line heater light will illuminate. The L1011-500 differences will be taught following each subject in which differences do occur. -100, -200 differences for ship number 724 will also be covered when necessary. If nothing is said at the end of a subject, assume both types of airplane, the -100, -200, and the -500 to be the same as the basic -1 airplane. -500 airplane general differences. The maximum weights for ship 724 when it is being operated as a -100 airplane are: taxi, 468,000 pounds; takeoff, 466,000 pounds, international operations; 430,000 pounds for domestic operations; landing, 368,000 pounds; zero fuel, 338,000 pounds, subject to certain conditions found in the limitations section of the pilot's operating manual. Fuel capacity, approximately 179,000 pounds. The maximum weights for ship 724 when it's being operated as a -200 airplane are: taxi, 476,000 pounds; takeoff, 474,000 pounds, international operations; 430,000 pounds, domestic operations; landing, 368,000 pounds; zero fuel, 338,000 pounds, subject again to certain conditions found in the limitations section of the pilot's operating manual. Fuel capacity, approximately 179,000 pounds. The maximum weights for the -500 aircraft are: taxi, 512,000 pounds; takeoff, 510,000 pounds, international operations; takeoff, 430,000 pounds, domestic operations; landing, 368,000 pounds; zero fuel, 338,000 pounds. Fuel capacity, approximately 212,000 pounds. The basic fuselage differences of the -500 from the basic -1, -100, -200 aircraft are: the fuselage is shorter. The -500 has only 3 sets of entry doors. The underfloor galley is removed, and the forward cargo door is much larger. Since there is no underfloor galley, 3 galley complexes are located in the passenger cabin. One is located at the number 1 door area. a second one at the number 2 door cross aisle, and a third located in the rear cabin number 3 cross aisle. The lavatories are located in approximately the same place in the forward and rear cabin. The Dash 500 aircraft has 10 flight attendant jump seats, 4 at the number 1 door cross aisle, 4 at the number 2 door cross aisle, and 2 at the number 3 door cross aisle. The potable water tank on the Dash 500 aircraft is located near the aft cargo compartment. The quantity and pressure gauges are located on the water service panel on the outside of the airplane below the number 2 right door. This is the same location as it is on the Dash 1 aircraft. The flight attendants on this airplane do not have water quantity and pressure gauges inside the airplane. Consequently, the second officer must check these indications on walk-around. The Dash 500 has only 3 pairs of entry doors. All 6 of these doors work just like the forward 6 doors on the Dash 1 aircraft. The forward cargo door is approximately 50% larger and is generally referred to as the C1A cargo door. The C1A cargo door is normally electrically operated. It can also be hand cranked. 2 cargo door warning lights, a forward cargo forward lock light, and a forward cargo aft lock light are installed on the second officer's annunciator panel. They indicate the status of 2 of the 8 door locks. A visual check of the 8 door locks can be made through 8 viewing ports on the bottom edge of the door. The 2 rear cargo doors on the Dash 500 aircraft and all 3 cargo doors on all other L-1011s have viewports installed on the top edge of the cargo door. This viewport, or window, is to be used to visually determine cargo door lock status in the event the cargo door warning light does not extinguish when the door is closed. This concludes Aircraft General. The pneumatic system. The pneumatic system control panel is located at the center of the second officer's upper panel. The control switches and pneumatic system schematic appear on the panel as shown. Consider the engines to be at the top of the panel, supplying pneumatic pressure to the 3 separate bleed channels down the panel. The 3 channels can be paralleled into a common cross-bleed manifold or isolated from one another by use of the cross-bleed valve switches. Each engine supplies low-pressure bleed air from the N2 compressor for the pneumatic system. This low-pressure bleed air is the primary supply for operation of the pneumatic system. The N3 compressor provides high-pressure bleed air to supplement the low-pressure bleed air when necessary to meet pneumatic system demands. This air is controlled by a high-pressure bleed valve. Located just above the engine isolation valve is an ejector that mixes high-pressure bleed air and the low-pressure bleed air to satisfy pneumatic system requirements. High-pressure air will be mixed with low-pressure air at low engine power settings. High-pressure air will also be added to supply a higher temperature when using wing anti-icing. The engine isolation valve, when open, will regulate pressure to approximately 40 psi. When the valve is closed, all pneumatic pressure from that engine is shut off. The high-pressure and engine isolation valves may be manually controlled using these switch lights on the pneumatic panel. With these switch lights latched, both the high pressure and the engine isolation valves are electrically de-energized and armed to open automatically with pneumatic pressure. The engine isolation valve will open when low pressure air is available. The high pressure valve will open when high pressure air is available and the pneumatic system demand requires additional air pressure or a higher temperature. The high pressure valve will close any time that the engine isolation valve closes for any reason. The flow bars on these switch lights will illuminate any time the respective valve is open. There is a pressure transmitter in each bleed channel, as shown in this plan view of the airplane. On the pneumatic panel, the pressure indicators display the pressure existing just downstream of each engine isolation valve. The three bleed channels may be interconnected or isolated through the use of cross-bleed valves that are controlled with these cross-bleed switch lights. When the switch lights are latched in, the valves will open when pressure is available on either side of the valve. The flow bar will illuminate when the respective valve is open. The remaining valve in the pneumatic system is the aft fuselage isolation valve. Its primary function is to provide the capability to isolate portions of the manifold so that a leak in one area would not necessarily cause a loss of pneumatic pressure to both air turbine motors. Pneumatic pressure supplied by the APU is introduced into the system as shown here. It can be monitored on the number 2 bleed channel pressure indicator any time that the APU bleed air shutoff valve is open. APU pneumatic pressure will also be indicated on the number 1 or number 3 pressure gauges if the appropriate valves are open. Caution: do not mix APU pneumatic pressure with any other air source. The valves discussed so far can be seen on the panel and on the plan view. Note that the blue color code represents the ducting from engines 1 and 3 to the cross-bleed manifold. Green indicates the duct from number 2 engine, while the cross-bleed manifold is colored in red. Air can be supplied from one or more external pneumatic connections. These connections are indicated by the arrows on the panel. A single channel or the entire manifold may be pressurized depending upon the position of the cross-bleed valves and fuselage isolation valve. Do not mix external pneumatic pressure with any other air source. The major items supplied by the pneumatic system are all 3 engine starters, wing anti-ice, both air turbine motors, and the 3 air conditioning packs. These pneumatic subsystems are depicted on the panel. Starting from the top of the panel, they are the engine starters, wing anti-ice, air turbine motors, and the air conditioning packs. The pneumatic system is provided with several protective functions. Some of these will provide indication only, while some others will take protective action. The nacelle pylon overheat detection system is designed to detect excessive temperature around the outside of the pneumatic ducting in the nacelle or pylon areas. The high temperature condition could be caused by a leaking high pressure pneumatic duct. This protective system will close and lock the high pressure valve for the appropriate engine. The duct overheat system is designed to provide protection in the event of excessive bleed air temperature inside the duct, just above the engine isolation valve. The protective action will be the closing of the high pressure and engine isolation valves. These valves will be locked closed until the duct overheat light extinguishes and the valve switch lights are unlatched and relatched. There is an overpressure valve located just downstream of each engine isolation valve. The respective valve will close if excessive pressure is sensed in the pneumatic ducting. When the overpressure valve closes, it will cause the engine isolation valve for that channel to lock closed, and the bleed duct overpressure light on the second officer's annunciator panel will also illuminate. The overpressure valve will reopen when the pressure decreases. When the engine isolation valve switch is unlatched, the bleed duct overpressure will extinguish. The engine isolation valve will reopen if the switch is latched back in. The high pressure valve is not locked closed by the overpressure condition, but the high pressure valve switch light may have to be unlatched if the overpressure occurs again. There are area overheat lights on the pneumatic panel. These lights provide an indication of excessive temperature around the outside of the pneumatic ducting. The area overheat detection system is a dual-loop detector system. If either loop senses an overheat, such as a leaking pneumatic duct or a shorted detector loop, the affected area overheat light will illuminate. It will also illuminate during a test of the area overheat detection system. The area overheat lights are located on the panel adjacent to the ducting they monitor. The upper three lights on the pneumatic panel monitor the ducting from the number 1, 2, and 3 engines. The left and right lights identified as D and E monitor the number 1 and 3 engine ducting. The center light, identified as J, monitors the number 2 engine ducting. The cross-bleed manifold is monitored by the lower light on the pneumatic panel and is identified as H. The lower 3 lights monitor the ducting from the center section forward to the air conditioning packs and are identified as A, B, and C. The ducting to the wing anti-ice system from the pylon's outboard are also monitored by the area overheat detection system. The anti-ice duct fail lights located on the overhead switch panel, identified as F and G, monitor this ducting. These letters are intended as an aid in choosing the proper procedure to be followed and for proper identification of the affected area for maintenance use later. The area overheat detection system is tested by a 3-position selector and a push-button test switch. When tested, all 7 area overheat lights on the pneumatic and air conditioning panel illuminate. The 2 wing anti-ice duct fail lights on the overhead switch panel will also illuminate. The area duct overheat light on the pilot's annunciator panel will illuminate anytime an area overheat or duct overheat light on the second officer's panel illuminates. It is also illuminated with the area overheat test. The sections of the pneumatic ducting that are located under the floor of the mid-avionics compartment are monitored for duct rupture and the resultant overheating. A failure of the ducting in this area could cause damage to the electrical and avionic equipment located in this compartment. If an overheat rupture occurs anywhere in the D area, the number 1 engine ducting, the E area, the number 3 engine ducting, or the H area, or the cross-bleed manifold, valves will automatically close to isolate that individual channel. For instance, if a rupture occurs in the number 1 engine channel, the D area, the number 1 engine isolation valve, the left cross-bleed valve, and the number 1 pack flow control valve will automatically close. The associated area overheat light will also illuminate. If a reset of these valves is required, all 3 switch lights must be unlatched before any valve can be reopened after the affected area overheat light has extinguished. If a leak is detected around the outside of the cross-bleed manifold, the H area, both cross-bleed valves, the fuselage isolation valve, and the number 2 pack flow control valve will automatically close. The associated area overheat light will also illuminate. If a reset of these valves is required, all 4 associated switch lights must be unlatched before any valve can be reopened, only after the area overheat light has extinguished. If the number 3 engine channel, the E area, is affected, the number 3 engine isolation valve, the right cross-bleed valve, and the number 3 pack flow control valve will automatically close. The associated area overheat will also illuminate. In this case, all 3 switch lights in the affected system must be unlatched before any valve can be reopened, after the affected area overheat light has been extinguished. An inhibit circuit is built into the D, the E, and the H detection systems to prevent a total pneumatic lockout, all valves closed condition. If, for instance, a rupture occurred anywhere in the number 3 engine channel, the E detection system would automatically close those affected valves. If in the remote possibility an overheat occurred in either the D and or the H areas, the D and H detectors cannot automatically close those remaining valves until the first overheat had cooled, light extinguished, thus preventing a total pneumatic lockout. In summary, 3 of the 9 areas will automatically close valves. They are the number 1 channel, the D area, the number 3 channel, the E area, and the cross-bleed manifold, the H area. These will automatically lock valves closed in their respective channels. The remaining 6 channels, however, do not close valves. They provide light indications only. They are the number 2 channel, the J area, the 3 air conditioning channels, the A, B, and C areas, and the wing anti-ice ducting, the F and G areas. Dash 500 pneumatic differences. If either or both air turbine motors have a run signal and the pneumatic duct pressure drops below approximately 15 psi, the number 2 pack flow control valve will automatically close. When the duct pressure again rises, or both ATMs lose their run signal, the number 2 pack valve will automatically reopen. This concludes the pneumatics section. Ice and rain protection. During the ice and rain protection program, we will discuss the following subsystems: ice detection, wing anti-ice, engine anti-ice, air data sensor heat, windshield heat and defogging, windshield washer and wipers, rain repellent, and drain mast heat. Ice detection. The ice detector probe, located on the underside of the aircraft nose, senses ice buildup and illuminates the icing light on the pilot's annunciator panel. The icing light remains on a minimum of 1 minute, or as long as icing conditions exist. Wing anti-ice. The wing anti-ice control panel is located on the pilot's overhead panel. It contains both automatic and manual controls for wing anti-ice. Air for the wing anti-ice system is available from the left and right ends of the pneumatic crossbleed manifold. The wing anti-ice valves are electrically controlled and require pneumatic pressure to open. The points at which pneumatic pressure is available for wing anti-ice are depicted here on the pneumatic panel. Note that the left and right ends of the crossbleed manifold must be pressurized for anti-icing to be used on both wings. Normally, the crossbleed valves are open, and all 3 engines are connected to the crossbleed manifold. When wing anti-ice is selected on, all high-pressure valves may open, depending upon engine power setting to provide sufficient temperature. There are 2 modes of wing anti-ice operation, auto and manual. With the auto switch latched, on is illuminated, and the wing anti-ice valve is energized to open with bleed air pressure. When the valve does open, the open light will illuminate in the bottom half of the manual switch. The hot air then flows through the inside of the leading edge slats and is vented overboard. The anti-ice valve will modulate to control the temperature to a specified value. With the manual switch latched, on is illuminated and the wing anti-ice valve is electrically armed and will open when pneumatic pressure is available. The open light illuminates when the valve is open. The valve will remain open in the manual mode regardless of the temperature in the slats. The wing anti-ice valves are normally inhibited from opening on the ground by the air-ground sensing system. The test button shown here provides the capability of testing the system while on the ground. When either the automatic or the manual switches are latched and air pressure is available at the individual valves, the open lights will illuminate as the valves open. The overheat light indicates excessive slat temperature when either the auto or manual mode is in use. The overheat system will not close the anti-ice valve. The switch would have to be unlatched. The duct fail lights will illuminate to indicate that the temperature in the area around the outside of the wing anti-ice ducting is excessive. A probable cause is a leaking duct. These lights are a part of the area overheat system and are designated as areas F and G. When a duct fail light illuminates, the area overheat test button and selector switch on the second officer's air conditioning panel are used to determine whether or not the light was illuminated by both overheat detector loops or by one loop only. The area duct overheat light on the pilot's annunciator panel will also illuminate. Engine anti-ice. The engine anti-ice control panel is located on the pilot's overhead panel. Each engine provides its own low-pressure bleed air for anti-icing. When the engine anti-ice switch is latched, the on light will illuminate to indicate switch position. The green heat light indicates that there is sufficient pressure in the system. The heat light may not illuminate at ground idle, but should come on as RPM is increased. The heated areas are the nose cowl inlet lip and the EPR probe. Each engine has a high-pressure relief valve protecting the nose cowl against overpressure. Should the nose cowl pressure increase above normal, the high-pressure light on the engine anti-ice panel will illuminate. The relief valve will vent the excess pressure overboard. Air data sensor heat. The air data sensor heat control panel is located on the pilot's overhead panel. The pitot-static probes, total air temperature probes, and angle of attack probes on the nose of the aircraft are provided with anti-ice protection. There is a captain and first officer pitot heat switch on the air data sensor heat panel. When the captain's switch is latched, heat is applied to a left and a right pitot-static probe. The first officer switch also applies heat to a left and a right probe. Each pitot-static probe has two heaters, one in the probe and one in the mast. Illumination of any of the four off lights indicates that one of the heater elements has failed. The mast light inhibit button is provided to aid in determining which heater has failed. When the mast light inhibit button is pressed, it inhibits the mast element signal. Therefore, if the mast element has failed, the off legend will extinguish. If the off legend remains illuminated, the probe element has failed. In the example shown here, the probe element has failed, so the off light would remain illuminated with the inhibit button pressed. Failure of a probe heater in icing conditions could affect pitot and static sensing. A mast heater failure would be of less concern. There are two total air temperature probes. Each probe contains a single heating element. Each off legend represents a probe. Normally, the switch is latched and dark. When the anti-ice element fails in a temperature probe, the off legend will illuminate. The indication shown here is a heater failure for the left temperature probe. When the alpha heat switch is latched, the heaters are operating for the left and right alpha probes. Due to the design of the system, the heaters must reach a specified temperature before the off lights will extinguish in the alpha heat switch. Therefore, it is normal for the off lights to remain illuminated for a short period of time after the switch is latched, and to remain extinguished for a short time when the switch is unlatched. The indication shown here is a failure of the left alpha heater. Windshield heat and defog. The windshield heat control panel is located on the pilot's overhead panel. With the captain's or first officer's windshield heat switch unlatched, the idle legend is illuminated. Low temperature heat is being applied to the captain's and first officer's windshield. High heat is applied to the captain's and first officer's forward windshield when the switches are latched and dark. The side windows operate at one temperature. Normally, the switches are latched and dark. Fault lights indicate a malfunction of the windshield heat system. Pressing the windshield heat test button will cause the four fault lights to cycle rapidly during a normal test. A failure to cycle indicates a malfunction. The captain and first officer switches may be latched or unlatched, but the side window switches must be latched for testing. The windshield defog fan circulates flight station air onto the windshields. Because of a considerable air blast with this fan, it is advisable to guard the eyes before latching the switch. It may raise some dust. Windshield washer and wipers. Both the captain and first officer have windshield wiper control panels located in the pilot's overhead panel. However, only the captain's panel contains a washer switch light. The washer switch, when pressed, pressurizes the windshield washer system and illuminates the pump on light. Pressing the switch again turns off the pump and extinguishes the pump on light. A combination reservoir pump is located in the forward avionic compartment. The reservoir holds approximately 1 gallon of fluid, which is routed from the reservoir pump through a manually controlled flow control valve for each windshield to the spray nozzles. A windshield washer flow control valve is located at each pilot's side console. These valves provide selective fluid flow to each windshield after the pump has been turned on at the captain's wiper panel. The windshield wiper control is a 3-position selector that turns on and controls the speed of the captain's windshield wiper. The first officer has an identical control for his windshield. Rain repellent. The rain repellent switches are on the windshield wiper control panels. Pressure for the rain repellent system comes from a pressurized can located at the aft end of the captain's side console. Actuation of the repellent switch ejects a measured amount of fluid onto that windshield. If more fluid is desired, press the repellent switch again. Holding the repellent switch will not create a continuous flow of fluid. Depending upon airspeed and rain conditions, each actuation should be adequate for 2 to 5 minutes. Approximately 75 applications are available in a fully charged repellent container. Rain repellent should only be applied in heavy rain with the windshield wipers on, and should be applied to only one windshield at a time. The rain repellent pressure gauge has a red and green arc. There is also a refill sight gauge below the pressure gauge. If the pressure gauge indicates in the red, or the refill float is in view, the system requires servicing. Drain mast heat. 2 wastewater drain masts are located on the underside of the fuselage to drain the galley and lavatory sinks. Each drain mast contains 2 heating elements. The masts are heated to a rather high temperature and are labeled hot, do not touch. The wastewater panel is located on the second officer's panel. The drain mast heater switches are normally latched. The number 1 heating elements are on and the number 2 heating elements are off. In the event of a failure, the number 1 legend will illuminate. Unlatching the drain mast heater switches will extinguish the number 1 legend and power the number 2 heating element. In the event of a number 2 heater failure, the number 2 legend will illuminate. This concludes ice and rain protection.
It is our pleasure to have you with us. Your safety and comfort are our primary concern, so please pay close attention to the following important information.
If you are seated in an exit seat, you must be able to see the exit, hear instructions, open the exit and verbally direct others to the exit. You must be able to do this without blocking the exit, causing harm to yourself, or being distracted by other attentions. Children under 15 may not sit in an exit seat. If you are sitting in an exit seat and do not want to sit there, please notify a flight attendant at this time. No smoking and fasten seatbelt signs are located throughout the cabin. Federal regulations require you to comply with these signs and crew instructions. Smoking is not allowed on board any Delta aircraft, and federal law prohibits tampering with, disabling, or destroying a lavatory smoke detector. To fasten your seatbelt, place the metal tip into the buckle and tighten the strap. To release, lift the top of the buckle. If the cabin pressure should change, panels above your seat will open, revealing oxygen masks. Reach up and pull a mask toward you. Place it over your nose and mouth and secure it with the elastic band. The plastic bag will not fully inflate, although oxygen is flowing. If you are seated next to a child or someone who needs assistance, put a mask on yourself first and then place a mask on the other person. Exits on the L-1011 are 8 doors, 4 on each side of the aircraft. If there is a loss of electrical power, emergency track lighting installed near the floor will illuminate. White lights lead to red lights, which indicate the exit. Please take a moment to look around and locate the exit nearest your seat. And be aware, your closest exit may be behind you. A portion of this flight will be over water, so we'd like to acquaint you with the location and use of flotation equipment. A life vest is located in a pouch beside or under your seat. Remove the vest from the pouch by pulling on the tab. Place the vest over your head and fasten the straps to the front of the vest. Adjust the straps loosely around your waist. For a small child, pull the vest over the child's head, with the back piece fully extended. Bring the straps up between the child's legs and clip in front. Tie the excess straps loosely around the waist. Do not inflate the vest inside the aircraft. As you leave the aircraft, pull down on the red tabs to inflate the vest. The vest can also be inflated by blowing into the tubes on either side. For a small child, inflate one chamber of the vest upon leaving the aircraft. For an infant, partially inflate the vest using one oral inflation tube. Lay the infant on the vest and secure with the straps. The L-1011 is equipped with life rafts, which may be detached for flotation. These are located at 6 doors. The 2 rear doors are equipped with inflatable evacuation slides, which may be detached for flotation. An additional raft is located in an aft stowage compartment. Your seat cushion may be used for flotation. To remove it, pull the bottom cushion up from the seat. Hold the cushion to your chest with the straps facing away. Put your arms through the straps on the underside and hold your wrists. All of this aircraft safety information can be found in the Passenger Safety Information Card located in your seat pocket. To prepare for takeoff, your carry-on items must be stowed, as well as footrest and in-seat video unit when applicable. Your seat belt must be fastened, and your seat back upright.
This concludes our safety presentation. At this time, flight attendants will be picking up cups and glasses and then must be seated for the remainder of taxi and takeoff. Thank you for your attention. We hope you enjoy your travel experience with Delta Airlines.